Hi, everybody. This is Mr. Keel. Today, we're going to be converting improper fractions to mixed numbers. Let's start with an easy example, 4/3. Now, what we've done before is we've drawn a picture. So this will be a little warm-up. What we've done is draw a picture. Look at that bottom. We're dealing with thirds. Here's 1/3. So the bottom says I need 3 of these to make one whole. We're dealing with thirds. Well, that's a third. And I need 3 of them to make a whole. Okay. Well, look at the top number. Top number says I have 4 of these. So let me pull out 4. There's 1, there's 2, there's 3, here's 4. 1, 2, 3, 4, just like the top says. Okay, well, how would I write this down? Oh, if I have 3/3 here, I have 3/3 right here, right? Plus I have 1/3 left over. 3 plus 1 is 4, so that's good so far. But what we're going to do today is actually 3/3 is the same thing as 1 whole. Right? This looks like 1 whole pizza right here. So 1 whole plus 1/3. Smush that together. 1 and 1/3. So 4/3 is the same as 1 and 1/3. That's what we've done before. We've kind of drawn a little picture, drawn that out. We're going to try it another way today. So we'll stick with 4/3, but we're going to try it another way. One way we can do that is we can write out the unit fractions. What is a unit fraction? It's a fraction with a 1 at the top. So 1/2. See the 1 at the top? 1/4. See the 1 at the top? 1/10. 100th. It doesn't matter. As long as there's a 1 at the top, that's a unit fraction. So what we can actually do is we can write out the unit fractions, right? We can say we're dealing with thirds, right? And we have 4 of them. There's a third, a third, a third, and a third. So I can actually write it out like this. I could write 1/3 plus 1/3 plus 1/3 plus 1/3. So far, so good. And the question would be, okay, well, how many can I circle to get to a whole? 1 whole. Well, I know if I have 3 of these, that's the same as a whole. So if I circle these 3, 1/3 plus 1/3 plus 1/3, that's 3/3. I have 1/3 left over. And it looks kind of the same thing, right? 3 over 3, 3/3, that's the same thing as 1 whole. Smush these two together. 1 whole plus 1/3, that equals 1 and 1/3. So we can also write out the unit fractions. Let's try a different number, a different fraction. Let's try, what if we tried, let's try 5/2. Okay, so we're dealing with halves now. Here's a half. So we're dealing with halves. And the bottom number says I need 2 of these to make a whole. Yeah, that sounds about right. The top number says I have 5. So there's 1, there's 2, there's 3, there's 4, there's 5. Squish them together. 1, 2, 3, 4, 5. Looks like I have 1, 2 wholes and a half, 2 1/2. One, 2, there's your 2. 1/2 left over, there's your leftovers. Well, what we can also do is we can write out the unit fractions, right? I can actually kind of write this out. 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2, right? 5 times. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Question is, how many can I circle to make a whole? How many will make up one whole? Well, if I have a half and a half right here, that's a whole, right? Right here, that's equal to 1. So I have one whole right there plus. Can I circle another 2? Yes, I can. Look, I can circle another 2. 1 half plus 1 half, that's 2 halves. And again, 2 halves, that's the same thing as 1 whole. Plus, okay, can I circle another 2? No, I only have 1 half left over. So go ahead and drop down that 1 half. Okay, this looks like a simple addition problem. 1 plus 1 is 2. Add your half at the end. There's your half. There you go. And it works. I can do one more problem. I'll do it a little faster for you, just so we can get a hint. What if we do 10/3? Well, does that mean I have to write 1/3 10 times? Yes, it does. 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. 1, 2, 3, 4, 5, 6. Plus 1/3 plus 1/3 plus 1/3 plus 1/3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So I wrote 1/3 10 times. Okay. How many can I circle to get a whole? If I have 3 of these, that's a whole. So there's 1 whole. If I circle 3 more, there's 2 holes. Can I circle 3 more? Yeah, right there. I can circle 3 more. So there's 3 holes. There's 1 right there, 2, 3. And there's a little bit left over. Well, 1 hole, 2, 3, plus my little leftovers. 1 plus 1 plus 1 is 3. Add your remainder, 3 1/3. So that's all good. But what happens if I do something like this? What if it gets kind of complicated, like 31/6? Uh-oh. Are you telling me I have to write it out 31 times? Well, you would. But that's not very practical. Doesn't make sense. There has to be some type of shortcut. There is a shortcut. All right, there is a shortcut. I don't want to write something 31 times. There's a shortcut here. I'm going to show you. One way we can think about it is this. How many times can 6 fit inside of 31? 6 can fit inside of 31 how many times? Another way to think about that is 6 times what? 6 times what will get me close to 31, but not over? 6 multiplied by what number will get me close to 31, but not over? Well, 6 times 5, right? 6 times 5 is 30. 6 times 5 equals 30. 30 is really close to 31. Cool. Well, how much is left over? Right? I just have to go over one more. I have to go up one more, right? If I'm at 30, how much is left over to get to 31? I only have to go up one more. So how much is my leftovers? I only have 1 left over. What are we dealing with? We're dealing with 6, right? There's your answer. So that's kind of a little shortcut. That's a shortcut we can use. I'll prove it to you using, instead of drawing it out 31 times, I'll draw little dots, all right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 31. Okay, there's 31 dots. I'll group them off into 6. 1, 2, 3, 4, 5. 2. There's one group. There's 2 groups. There's 3 groups. There's 4 groups. There's 5 groups. Hey, I have 5 groups. Look at that. Look at my hole. It's a 5. I have 1 left over. Hey, 1 left over. That's not a coincidence. Okay? Let me try it with another problem. Let's try with a little bit easier problem. Let's do something like 13/4, okay? So here's the question. How many times can 4 fit inside of 13? How many groups can I make? Another way to think about that is 4 times what number? 4 times what will get me close to the number 13, but not over? Well, 4 times 1 is 4. That's too small. 4 times 2 is 8. Yeah, but I think I could fit another group in there. 4 times 3 is 12. Hey, that's pretty close. 4 times 3. 4 times 3. 4 times 3 equals 12. And 12 is really close to 13. Cool. Now, how much is left over? If I'm at 12, I need to go up to 13. How much more do I need? I only need 1 more, don't I? So I'll put a 1 right there. What I put for my denominator? Well, what are we dealing with? We're dealing with fourths. Go ahead and put a 4th right there. Boom. There's your answer. And I'll prove it to you with little dots, all right? Instead of writing 1/4 plus 1/4 plus 1, instead of doing that, I'm just gonna put little dots to make it easier, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, groups of 4. There's 1 group, another group of 4. There's 2, another group of 4. There's 3. Can I do another group? No, I can't. So how many groups do I have? I have 3 groups. Hey, what do you know? There's a 3. How much is left over? 1. What do you know? 1. Okay, let's try one more time, all right? Let's try 18/5. Okay, same question. How many times can 5 fit inside of 18? How many groups of 5 can I fit inside of 18? 5 times what will get me close to 18, but not over? 5 times 1 is 5, now too small. 5 times 2 is 10. I can fit another group, I think. 5 times 3 is 15, that's pretty close. 5 times 4 is 20. 20? Nope, too much. So let's go with 5 times 3. Because 5 times 3 equals 15. 15 is close to 18, cool. Well, how much more do I need? If I'm at 15 and I have 18, well, how much is left over? 16, 17, 18. 1, 2, 3. 3 is left over, right? If I'm at 15, 16, 17, 18. 3 is left over. I'm going to put 3 right there. I can't talk today. What do I put down here? We're dealing with fifths. Go ahead and put a 5th. Boom, there's your answer. 3 3/5. Let me prove it to you with little dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 dots. I'm going to group them into groups of 5. There's 1 group. 2 groups. 3 groups. Is there another 5? Is there another group of 5? No, I only have 3. Okay, so we'll stop there. How many groups do I have? 3. Hey, 3. There's 3. How much is left over? 1, 2, 3 is left over. Hey, 3 is left over. All right, so that's how we're gonna, those are some different ways that we can convert improper fractions to mixed numbers. Good luck, everybody.